Hello, everyone, and welcome back to the next installment in this series of videos. Today, what we're going to talk about is one of the most important things from this first unit, which is how do you actually describe a distribution. This is incredibly common, something that you will most likely see in the first free response question on the exam. And it's a fairly simple topic. However, you need to be very, very careful with your wording and the specificity in terms of when do we know things or when do we not know things. And so it's something that is very simple, but we have to pay some really close attention to detail. So let's get into it here. Now, when we describe distributions, this is very, very similar to a lot of other things that we're going to talk about, but I have an acronym for this, and it's SOX. The four specific things that you need to talk about: shape, outliers, center, and spread. And so breaking this down, you hit these four incredibly important bullet points, you're in the clear. Now, again, there's a caveat here, and we need to make sure that we're being specific enough without being too specific. But I think going through a couple of examples will be helpful for that. So, when we talk about shape, specifically here when we talk about histograms, you really have four options for shape. You have your approximately normal, you have skewed left or right, oops, now remember, for these, skew follows the tail. So skewed left means you have low outliers. Skewed right means you have high outliers. And then the last one that you may see on the exam is bimodal, which just means that you have two peaks instead of one peak. All right, so think about like a cosine curve or a sine curve. You have two high points. Now, with a box plot, remember from the previous video, all we can talk about here is symmetry. So you either have a box plot that is symmetric or asymmetric or not symmetric. Now, one important phrase that I'd like to include here when we're talking about shape is the phrase appears to be. The use of non-deterministic language is incredibly important for this description. If you say that something is normal, you will lose points if it is not perfectly normal. So using the phrase appears to be bimodal takes care of that non-deterministic language that is so incredibly important. Same thing for a box plot, saying that it appears to be symmetric or it is roughly symmetric. Incredibly important, because otherwise you may lose a very silly point on a free response question. This is not the reason why you want to be losing points. Right? If you lose points on the AP exam, you want it to be because you didn't know how to do something, not because you forgot the word appears or approximately or roughly. So moving on to our second point here, outliers. Now again, with histograms, we don't know. So I like to use the phrase possible or potential outliers as a qualifier. The other important thing is to give the location. If you're going to say that there are possible outliers, tell them where they are. There appears to be an outlier at 25. There appears to be an outlier at 32. There is a potential outlier around 7. Right? If it's a histogram, you can also give the interval. There is a potential outlier between 20 and 25. Give the interval that it's in. Now, the other important thing here with box plots is that, or the difference, I should say, is that now you know. Remember from the previous video, if you have a data point that is less than Q1 minus 1.5 the IQR, or if you have a data point that is greater than the third quartile plus 1.5 the IQR, you know for a fact. So with a box plot, you can use some more deterministic language if you'd like to, in saying, yes, there is an outlier and here's where it is, because now we have those fences. With a histogram, we don't have that. When we talk about center, regardless of the data display you have, always use the median. I cannot stress that enough. Your only difference here is that with histograms, you're going to give the interval. For example, you would say something like the median appears to be between $5 and $7.50 and give the interval that it's in. Versus with a box plot, you can give the value or give the approximate value. Kind of depends on where it is, depends on how they label the box plot or how they label the number line. Sometimes you're given the 5-number summary, so you can just use that. But otherwise, you can be a little bit more specific with a box plot and say, it's here. Because remember, it is the second vertical bar in your box. It's the middle of the box in your box plot. And now, the last thing for spread, we have a couple of options. With a histogram, I tend to go to one thing. With a histogram, I tend to go with the maximum range. So I take the highest point of the last interval and the lowest point of the first interval and subtract them. The word maximum here counts as your non-deterministic language. Very simple. With a box plot, you have a couple of options. In reality, you have two options. With a box plot, you can either use actual range, because again, you'll know the maximum and minimum. And if you don't, you can then use the approximate range. Or you can use the IQR, the interquartile range, which is the middle 50% of your data. So that is the big four things we have to talk about. I have an extra slide here of histogram versus box plots. However, right, the biggest difference here with this is that histograms, we're less sure about a lot of things. However, with box plots, we only know symmetry. I talked about all of the other differences earlier on. So I figure the most helpful thing to do here is to actually take a look at some released free response questions and look at what we would say. Now, I'm not going to write a full response to those. I may just talk through what I would say, or I may write some bullet points, but we'll kind of see here. So the first example here is from 2 years ago, 2023, number 1. And it asks you here to describe the distribution, right? If you see these words, little question strategy, if you see the words describe the distribution, this automatically means SOX, right? And so other thing to understand here, you get no points for writing SOX, the acronym. They're just the bullet points and the way to remember what you need to say in order to earn credit. So for this one, I can fit it. So for the shape here, I would say that this appears to be skewed left. And the other thing that's important regarding the exam here is that for this particular one, like, it will be obvious. It will be so obvious. They're not going to give you something where you have to kind of like guess, is this normal? Is it skewed? It's going to be very, very obvious. Like this one. Outliers. We have potential outliers. Again, notice the wording. at. I'm going to say here, somewhere between 5 and 6 milligrams per liter, 4 and 5 milligrams per liter, and 2 to 3 milligrams per liter. Right. Again, note I'm highlighting these 3 areas here as my potential outliers. Oftentimes, the giveaway for outliers are going to be the intervals that have the least amount of frequencies and obviously are very close to the ends of your number line. The center here, you're given a total number of data points in this particular one. So you could actually count to figure out where the median is. I cut that part of the question out. It was in the initial context at the beginning. I forget. However, typically your median is going to be where you have the most amount of data. So I'm going to say my median is between 11 and 12 milligrams per liter. Now, one thing that's really important here that you should hopefully notice as I'm going through this is that I am including units in my answer. Context is everything when it comes to these particular types of questions. And now lastly, for the spread, for this one, I don't have a lot of room left to write. But for the spread, I would just say the maximum range is 12. One thing that's really important when you talk about range is a number. The maximum range is not 2 to 14. The maximum range is a number. So here, the maximum range would be 12 milligrams per liter. So there's one example of what you might see. Now, this is what I'm going to talk through roughly, as opposed to writing the whole thing out. Because as we can see here, this one's a little bit different. Right now, this is another histogram. Typically, they will ask you to describe the distribution of histograms. I've seen box plots a few times, but I picked this question specifically because of what they have you do at the end. Right, so for this one, the shape is that it appears to be bimodal. That's very obvious. The median is most likely between, I believe if you actually count this one out, it's 20 dorm rooms. So it's between the 10th and 11th data point. So it is somewhere between 200 and 300. The 10th data point is from 200 to 250. The 11th is from 250 to 300. So anywhere between 200 and 300 square feet. There are no potential outliers in this one, or no obvious outliers in this one. And the maximum range is 250 square feet. The reason why I picked this one is that now they have you make the box plot. So my minimum here, notice they give you the 5-number summary right here. And so the minimum is 134, so that's going to be somewhere close to the middle here. Your first quartile is 174. The median is 253. Q3 is 293. So this is going to look something like this. And then the max is 315, which will be somewhere here. Now, it does say to determine whether or not there are any outliers. It does turn out if you do the outlier fences, there are none. There's a giveaway in this question that there are none, is that they didn't give you anything but the 5-number summary. So you wouldn't know what to draw your whisker to if you had a high outlier. If 315 was an outlier, I wouldn't know what to draw to because they didn't give me anything else. Same thing if 134 was an outlier. I wouldn't know what to draw to because they didn't give me any other data point. Now, here's my box plot, which appears to be fairly symmetric. And again, this is a very rough sketch of mine very quickly. I didn't actually meter this out to determine exactly where things should be. But what's interesting is the very last question, which is, what characteristic is apparent from the histogram, but not from the box plot? This is meant to illustrate that you cannot tell shape. And the answer to this is the bimodal shape. A bimodal distribution is symmetric. And so the box plot will appear to be symmetric. This question is incredibly important in showing that you cannot tell shape from a box plot. All I can tell is whether or not the graph is symmetric. The histogram was symmetric. The box plot is roughly symmetric. However, I have no clue what that symmetry looks like. It could be uniform, it could be bimodal in this case, it could be approximately normal, it could be anything. So remember, when you're describing distributions, SOCS, shape, outlier, center, spread. See you in the next one.